Hey guys, this is Mrs. Mooney. If you're watching this video, you are in Group 1 and you're practicing your dilations. All of the practice problems we're going to work on today will have a center of dilation at the origin, right here. So remember, if the center of dilation is not on the border of the figure, then as we grow the figure, the dilated figure will grow out from the center of dilation, and as we shrink the figure, if we wanted to use a smaller scale factor, everything would shrink toward the center of dilation. So let's start with this first example. Graph the image of rectangle Klmn after dilation with a scale factor of 2 centered at the origin. We could do this a couple of different ways. I'm going to count the distance from the center of dilation to each vertex. So I'm going to start with vertex L, and notice it's 2, 4 on the x-axis and 2, 4 on the y-axis. And recall that our scale factor is 2. So I have to double those distances. So instead of going 4 on the x-axis, I'll go 2, 4, 6, 8. And instead of going 4 on the y-axis, I'll go 2, 4, 6, 8. So that puts my dilated point, my L prime, right here. So I'm just going to clean this up a little bit. And let's do M next. So we're counting the distance from the center of dilation to vertex M. On the x-axis, it's 2, 4 units away, and on the y-axis, it's also 2, 4 units away. So I'll double those distances. On the x-axis, instead of 4, I'm going to go 8, and on the y-axis, instead of 4, I'm going to go 8. So that gives me my M prime right here. And I'm going to clean up a little bit and move on to the next point. All right, so now we're going to work on vertex N, starting from the center of dilation, and in this case it's the origin. This one is 2, 4 units away on the x-axis, and again 2, 4 units away on the y-axis. So I'm going to double that. Instead of 4, I'm going out 8, and instead of down 4, I'm going down 8. So that gives me my dilated vertex N, which is N prime. And now we just have one more to go, so let's clean this up. And now we are going to dilate vertex K. So starting at the center of dilation, again, it's 2, 4 on the x-axis and 2, 4 on the y-axis. So we'll double those distances, 4, 6, 8, and 2, 4, 6, 8. So that gives us our K prime. I'm going to connect all of our points with lines to show our new dilated figure. So we did that by counting the distance from the center of dilation out to each of the vertices. Another way we could have done that is simply by listing all of the original coordinates. Whoops. Our original coordinates are K, L, M, N, and they are at, K is at -4, +4, and L is at 4, 4, M is at 4, -4, and N is at -4, -4. So with a scale factor of 2, we could simply multiply each x and y coordinate by the scale factor. So -4 times 2 is -8, and 4 times 2 is 8. 4 times 2 is 8, and 4 times 2 is 8. 4 times 2 is 8, and -4 times 2 is -8, and -8 and -8. So these are our K prime, L prime, M prime, and N prime coordinates. And notice if I look where I plotted L prime, it's right here at 8, 8, just like our L prime here is. And my M prime is at 8, -8, just like I have here. So you could do your original dilation by using the original coordinates and just multiplying by the scale factor, or you could actually count out the distance from the center of dilation to find your new coordinates, and then check using this method of multiplying the old coordinates by the scale factor to get the new coordinates, and make sure that's what you actually came up with when you were counting out your distances. All right, so let's clean this up a little bit. You should have on your note sheet here, you should have the drawn dilated image, and you should also have all of your new coordinates listed over here. So this is K prime, L prime, M prime, and N prime. And it helps to have the originals listed as well so that you can see the transformation as just a multiplication by the scale factor. So let's move on to the next example. All right, we've got example 2 here. Graph the image of rectangle PQRS after dilation with a scale factor of 1/4, centered again at the origin. So remember, with a scale factor of 1/4, our image is not only going to shrink, but it's also its distance from the center of dilation is going to get closer to the center of dilation, closer to center, because the scale factor is 1/4. All right, so let's get started here. Okay, I'm going to count the distance of each vertex from the center of origin, the center of dilation, which is the origin 0, 0. All right, so let's start with P. P goes down 4, and it does not go left or right at all. So we only have to cut this distance of 4 by 1/4. So 4 times 1/4. Remember, 4 is the same as 4 over 1. So that equals 4 over 4. That equals 1. So instead of going down that distance of 4, we're just going to go down a distance of 1. All right, so we're going to go right in between these here. All right, now let's do Q. All right, so Q goes over 8 and down 4. 1/4 of 8 is 2, so I'm going to go over 2, and 1/4 of 4 we already found out is 1, so I'm going to go down 1 this time. I'm cutting both of those distances by 1/4. Now let's do R. So again, R goes over 8, and it goes down to -8. So 1/4 of 8 is 2. So I'm going to go over 2, and I'm going to go down 2. So that's my R prime. I should have been marking these. Q prime, and this over here is P prime. And finally, we have S prime that we're going to do. So S is down 8, and it's not left or right at all. So I'm just going to cut that distance of -8 by 1/4. So that's going to be -2 right on the y-axis. So I've got this tiny little figure here. Oops, that's my S prime. I have this tiny little figure here, which is our original figure, which is 1/4 of our original figure. And that kind of looks like it's about 1/4. So another way we could have done this, or a way that we could check our work to make sure it's accurate, is by using the original coordinates and multiplying by the scale factor. So let's write down the original coordinates of PQRS. So P is at 0, -4, x value of 0, y value of -4. Q is at 8, -4. R is, where's R? 8, -8. And S is at 0, -8. So we're going to multiply the x's and the y's by 1/4, which is the same as dividing by 4, right? So 0 divided by 4 is just 0. -4 divided by 4 is -1. 8 divided by 4 is 2. -4 divided by 4 is -1. 8 divided by 4 is 2. -8 divided by 4 is -2. 0 divided by 4 is 0. And -8 again by 4 is equal to -2. So let's verify that these new coordinates are in fact what we graphed when we originally dilated our figure. So is P prime actually at 0, -1? Let's see, 0, -1. Yep, that's where P prime is. Is Q prime at 2, -1? 2, -1, it is. How about R at 2, -2? R at 2, -2, check. And finally S at 0, -2, and that is where our S is, or S prime, I should say. So we verified that our dilation using distances was correct by using the original coordinates multiplied by the scale factor. So notice when the scale factor is less than 1, the image gets smaller, but also the image gets closer to the origin, which is the center of dilation. All right, let's do another example together. So we're on the next page on number 3. And this time I encourage you to pause the video before I make a move and see if you can make the move, and then restart the video and check your work. All right, this time we are dilating figure EFGD with a scale factor of 3 and again centered at the origin. Since the scale factor is 3 and that's greater than 1, this image is going to be getting bigger, and this image will be getting farther away from the center of dilation, which is the origin. Farther away from the origin, the center of dilation. So keep that in mind. All right, let's go in order. Let's start with D. D is, it looks like it's about halfway between -2 and -4. So let's call that -3 on the x-axis. And we'll call it -3 on the y-axis as well. So we went to the left 3 and down 3. And our scale factor is 3. So I need to triple those distances. So instead of going to the left 3, I'm going to go to the left 9. And instead of going down 3, I'm going to go down 9. So that puts my D prime right here. That's at -9, -9. All right, let's keep going with E. So E, it looks like it is, again, -3 on the x-axis, and this time +3 on the y-axis. So if I triple those distances, instead of going to the left 3, I'm going to go to the left 9, and instead of going up 3, I'm going to go up 9. So let's erase those. So that is my E prime. Those coordinates are -9, +9. And let's move to F. F is at 2, 3. So we're going to triple those distances. 2 times 3 is equal to 6. So I'm going to go 6 on the x-axis. And we had gone 3 on the y-axis. 3 times 3 is 9. So I'm going to go up 9 on the y-axis. So that puts us at 6, 9 for our F prime. All right, and finally we're going to do G prime. So starting at G, which is at 2, 0. It doesn't go up or down on the y-axis at all. It only goes out 2 on the x-axis, and we're going to triple that. So we're going to go out 2, 4, 6. And that's our G prime, and that's at 6, 0. All right, let's connect the dots to draw our figure. All right, and there's our dilated figure with a scale factor of 3 centered at the origin. All right, and we can double check this by comparing original coordinates for D, E, F, G to the new dilated coordinates. So let's write down those original coordinates. There's D and E at -3, +3, F at 2, 3, and G at 2, 0. If we were to multiply each of these original coordinates by our scale factor of 3, we would get -9, -9. E prime would be -9, +9. F prime would be 6, 9. And G prime would be 6, 0. So let's check. Is D prime actually -9, -9? Here it is down here. It's -9, -9. Is E prime -9, +9? Here's E prime at -9, +9. Is F prime at 6, 9? Yep. And is G prime at 6, 0? Those are all correct. So we've double checked our work using the original coordinates multiplied by the scale factor. And I want to clean this up a little bit because I want to show you one more method that you could have used to check your work. Remember, you should be able to connect all of your corresponding vertices with the center of dilation. They should all lie on the same line. So let's find our corresponding vertices. For F, it corresponds to F prime. So we should be able to draw a straight line that goes from the center of dilation through F and F prime. And same thing with G and G prime, and you can see that those lie right on the x-axis, so that works. And D prime, I'm going to draw it the other way because it's a little bit easier. Those line up. And then E and E prime. See if I can get it to go through here without a ruler. So you can see that's another way of checking that we did our dilation correctly. It means that the dilated image is proportional and similar to the original image because the corresponding vertices line up with the center of dilation. So at this point, I want you to try the rest on your own, and then I want you to come back to the video after each one just to double check your work. So you should check that your figure looks like my figure, P prime, Q prime, R prime, S prime. And you should also check that you have all of the correct dilated vertices. A final way you can check is by starting at your center of dilation and drawing rays out through the center of dilation, connecting each set of corresponding vertices like this. Okay, for F, G, H, I, and F prime, G prime, H prime, I prime, check that you have the correct vertices for your dilated figure. Check that your image looks like my image. And a final way you can check is by finding your center of dilation and connecting corresponding vertices to the center of dilation. So notice there are two sets of corresponding vertices that line up on that line. All right, on this line, we can connect that 90-degree angle. And then here, we can connect the peaks. So we verified two ways that we have the correct dilation. Verify all of your coordinates and verify your drawing in the coordinate plane. And then find your center of dilation and connect your corresponding vertices and the center of dilation. For number 7, verify your coordinates, verify your drawing, find your center of dilation, and connect your corresponding vertices. For number 8, verify your coordinates, verify your dilated figure in the coordinate plane, find your center of dilation, and connect your corresponding vertices. This one's easy because they all lie right on an axis. Perfect. Verify your coordinates, verify your drawing, find your center of dilation, connect your corresponding vertices. These two sets lie right on the axis. And then the R's line up like this, and the U's line up like this. One more to go. And finally, for number 10, verify your coordinates, verify your drawing, find your center of dilation, and connect your corresponding vertices.